Last couple of things we can look at. One which is quite straightforward, and then the other which is going to be a bit more involved. The first bit, we've started thinking about this in terms of minimal use of language. So just presenting an example sequence, having the example sequence do the communicating. And in this instance, you experience this problem where you run into, well, basically kids not getting it. And I've suggested that's because it's too hard to know, given the examples I shared at the beginning, too difficult to know exactly where we should be attending. So it's an attention problem. What is the thing that matters? I've suggested that that could be improved upon by changing the examples in the sequence. Despite that, I would probably still opt for this second option, which is the correlated feature sequence, where we are going to verbally direct attention to what matters each time. There is a third and final option which maximizes the use of language, and that would be what's called a rules-based approach. So with this example, we would state a rule up front, and then we would demonstrate the rule in use. For example, I'm going to teach you what we mean by quadratic expression. Here's the rule. The rule is if the highest power on the variable is 2, then it is a quadratic expression. Once again, the rule is if the highest power on the variable is 2, then it is a quadratic expression. What is the rule? And then, depending on the class, might ask for a call response, where they just all call out the rule I've just repeated together. Okay, my turn first. This is not a quadratic expression because the highest power on the unknown is not 2. I would also probably overtize that. This is a quadratic expression because the highest power on the unknown is 2. This is a quadratic expression because the highest power on the unknown is 2. This is not a quadratic expression because the highest power on the unknown is not 2. And so on and so forth. But the difference this time is a rule is being stated up front. That allows us to maximally direct attention in advance. Possible downsides. One is the rule immediately understandable. There are some concepts, surds is always an example I go to, and density is another one, where it's very difficult to explain what matters in words in a way that is immediately meaningful before presenting the examples. The second thing that I always think about is what the experience is going to be like for students and which is more engaging. If 100% of your experience is rules-based and you're being told the rule up front all the time, if I contrast that to an alternative where sometimes the rule is not being stated up front, or I'm not using correlated feature sequences, and attention can still be carefully directed to the thing that matters, and there's an extremely high probability that they will see what it is that is changing and that is making the difference between positive and negatives, then I think that sets up what I've called before micro problems. There are these wonderful opportunities to realize what it is that is making the difference. Sometimes what I might do is, let's say I've gone through a sequence. Let's actually demonstrate this. Let's say we go through the sequence like this. A non-correlated feature this time, just categorical. I'm going to teach you what we mean by quadratic expression. So my turn first. For example, this is not a quadratic expression. Watch what I change. This is a quadratic expression. This is not a quadratic expression. No, sorry, let me just do that again. Okay, teach you what we mean by quadratic expression. My turn first. This is not a quadratic expression. I'm going to change one thing. Watch what I change. this is a quadratic expression. This is a quadratic expression. And this is a quadratic expression. But this is not a quadratic expression. Each time, if the highest power on the unknown is 2, then it is a quadratic. If the highest power on the unknown is not 2, then it is not a quadratic. So in that example, although I wasn't explaining what mattered from one example to the next, I shared it at the end. So that is another option. I would still probably go with the correlated feature sequence, but this is another option as well. And in general, even if I'm 100% sure it's going to be clear what matters, I now tend to always add at the end of the sequence what it is that is making the difference each time.